In this question, we want to find the magnitude of the current through the 10 ohm resistor, and we also want to find the direction of that current. So let's solve this as a Kirchhoff's law problem. First thing we'll do is identify each of the currents. Let's say that this branch has current that we'll call I1, and that goes through the entire branch. Let's call the current in this branch I2. I don't know which way the direction flows. I'm going to pick that it flows from left to right. If I'm wrong, then when I solve my problem, I'll see that my answer for I2 would be negative. That would show me that I picked the wrong direction. So I'm just going to guess randomly that it goes from left to right. And then the current in the third branch we'll call I3, and that goes through the entire third branch, I3. Next thing we'll do is we'll write down Kirchhoff's laws. Let's pick two loops. For my first loop, I'm going to pick the outside loop. I don't want to mess up that diagram too much, so I'm going to redraw it over here. Okay, so there's my redrawn circuit. For this loop, I'm going to pick the outside loop. We'll call this loop 1. The things that we'll be including in loop 1 are the 5 ohm resistor, the 12 volt battery, the 5 ohm resistor down here, and this 9 volt battery. So let's write the equation for loop 1. We have a 12 volt increase. We have a drop of V equals IR across the resistant. The current through this branch is I3. So we get minus 5 ohms times I3. Come to this battery, we get a voltage increase of 9 volts. Come to this resistor, we get a voltage drop of 5 ohms times current I1. And then that all has to give 0. So there's our loop rule for loop 1. Let's draw a second loop. And again, I don't want to mess up the diagram, so I'll just quickly redraw it down here. For the second loop, let's include branch 2, and let's just pick the upper loop. Doesn't really matter which one you pick, it'll work out right anyway. This is our 12 volt battery, 5 ohm resistor, and this one is the 10 ohm resistor, and this one is the 3 volt battery. Writing Kirchhoff's law for loop number 2, we have the 12 volt battery, increase in potential. We get a drop through the 10 ohm resistor, so minus 10 ohms times I2. A 3 volt increase due to that battery, and a drop across this resistor. So there are Kirchhoff's laws loop rules. We see that we have I1, I2, and I3 in our equations, which means we have 3 unknowns, which means we need a third equation. For our third equation, we'll write down the current law. Current law says that whatever current comes into a junction also comes out of the junction. Let's look at this junction right here. Current I1 flows in, current I2 flows out, current I3 also flows out. So there are 3 equations with our 3 unknowns. We can now solve this problem. If we come up to loop 1, let's rearrange this equation and let's solve it so that we get something that says I3 equals something in terms of I1. So we have 12 volts plus 9 volts minus 5 ohms times I1 equals 5 ohms times I3. We can solve for I3. I3 is 12 and 9, that's 21. 21 volts minus 5 ohms times I1 divided by 5 ohms. 21 volts over 5 ohms gives us 4.2 volts over ohms is amps. 5 over 5 is 1 minus 4I1. So there's an expression for I3 as a function of current. In loop number 2, we have 12 volts plus 3 volts minus 5 ohms times I1 equals 10 ohms times I2. We can solve this for I2. I2 is 12 plus 3 volts, 15 volts, minus 5 ohms times I1, divided by 10 ohms, gives us an expression for our I2. 15 volts over 10 ohms equals 1.5 amps. minus 5 ohms over 10 ohms equals 0.5 times I1. There's an expression for I2. Let's put these expressions into the current law, and then we can find our current I1. I1 is 1.5 minus 0.5 times I1 plus 4.2 minus I1. So then I1 is equal to, let's see, 1.5 plus 4.2 gives us 5.7 minus 1.5 times I1, which means I1 is equal to 5.7 over 2.5, or 2.28 amps. There's our current I1. Now we can use this to find our current I2. Means that I2 is 1.5 amps minus 0.5 I1 equals 0.36 amps. I got an answer that's positive, which means I did pick the right direction when I started my problem, so the current flows from left to right.